All right, so 10 graphing problems, I think, roughly 10 graphing problems. Trying to get to the point where we can look at things and do things quickly. So let's try to do things quickly today. So I see a function that's decreasing because I've got a plus and equals a constant. So as this goes up, that has to go down and at a certain ratio. But the quick way to graph this, again, I'm looking for zeros. Put a 0 in, my y is 30 over 7, a little bit bigger than 4. Put a 0 in for y, I get 10. So that's easy to graph. All right, so 10 gets you 0. And I'll use the axes because we are finding 0 gets you 30 over 7. We are finding intercepts. So I'll use the xy axis, put that in a bad spot. Should know better. 10, 0. Arrows would be nice. A full linear statement would be nice, or picture. And deductions if not. All right, very nice. If you can locate two quick points here, 5 gets you 2. Going up 4, 9 gets you down 3, 1. No, that's not down 3. -1, okay? And so just plot those points. XY axis necessary? Not really. So there's 5, 2. And there's 9, so I gotta put that in another bad spot. Okay, I got something to erase with here, because I really do want to show the over 4 people just learning here, down 3. Right, so I've got myself a nice linear function. Doesn't hurt to label 5, 2 for the reader, and then 9, -1. And of course, you don't have to show the over 4 down 3, but it's helpful as a learning tool. So hoping to see something like that. All right, now when I graph linear functions, I read them, polynomials, I read them backwards. So I know I'm starting at 0, 7, and I know I'm going down at 12 to 1. And I've shown that in previous videos. You start at 0, you get 7. You can see that, get rid of the variables, right? Put 0.001 in and look at the numbers. These are the numbers. Well, that doesn't change. We've talked about that. You're going to write to me if you see that change. Okay, we'll get you some help. That's so small, we can kind of ignore it. And if I divide by 0.001, I have the change in y over the change in x. Sure looks like I'm going down at 12 to 1. Must be a coincidence. And I do know that 2x squared, once x gets past 1, going up. All right, so once I get past 1, this term starts to really kick in, which means that I have a cup shape up. And now I know that that's positive, so all I got to do is divide 2 into 12, 6, cut it in half, and I know I'm at 3. I don't even have to worry about signs anymore. And if I put 3 in, I get -36 minus 18 plus 7. I know I'm at -11. Now I have my roots, right? The roots we can see are x equals, you're measuring from 3 and -11 to 0. I got to get to 0. So I got to go up 11 units, but I got a multiplier of 2. So there are the roots. Nothing wrong with knowing that. Sketching. Well, you got to understand 3x minus 6 is a linear function. Cuts through the x-axis at 2. And if you slap an absolute value, then all these positives stay the same, but all these negatives become positive. So this thing hinges at x equals 2 because that makes the absolute value of 0, which is a minimum. And that's positive, so we're going up. And I know if I put a 2 in, I'm going to get 2 times the absolute value of 0 plus 4. So therefore, I know that's a 4 because this fits the absolute value of x minus h plus k format. The only thing is I'm putting a function in here, which, you know, you'll study the chain rule some point in time in calculus. You'll find out the rate at which things are changing, and they're changing at 6 to 1. I'm going up at 6 to 1 on this side. I'm going down at 6 to 1 on that side. How can we verify that? Let's put a 0 in and verify that I'm going down at 6 to 1. So 0 minus 6, 6 times 2, 12 plus 4, 16. Well, you tell me how you get from 16 to 4, and I'll tell you I think you're going down at 12. And how do you change from 0 to 2? I think you're going up 2. I think I'm going down at 6 to 1 on this side, and I'm going 6 to 1 at that side, and it hinges at 2. I think I have myself a piecewise function. where I'm going down at 6 on this side and I'm passing through 2, 4. And that is only true when x is less than 2, and I'm going up at 6, including the 0.24. And now we're talking piecewise functions. Bunch of things asked there. And I could easily solve piecewise functions. Let's solve it for 16. We know we get a 0, and we know we get a 4. So let's solve this real quick for 16 to see a 0 and 4 come up. These are all the things we're doing with absolute values, so we might as well do them all right now. It doesn't take long. Let's set this to 16. Going to subtract 4. It's 12. You're going to divide by 2. It's 6. You're going to now be at the absolute value of 3x minus 6 equals 6. So 3x minus 6 has to equal plus or minus 6. Let's put plus 6 here. Let's put minus 6 there. Let's add 6. That makes that 0. Oh, that makes it 12. Excuse me. That makes that one 12. Let's subtract 6. Let's add 6 to this side. That makes that one 0. Let's divide by 3. That makes that 4. That makes that 0. What's in between 0 and 4? Let's put the 0 on this side, 2. And remember what we had, a V shape. And we hit 16 at 0. I hope that's what it was before. And 16 here as well. And that's 4. Okay. All right. Minus 2 times x plus 5 minus 3 equals a graph. Hope you can see this because the sun's hitting this board, and I've noticed that we get all kinds of problems when that happens. I don't think it's so bright that you can't see it. So what do we have? We have a square root function going down. -5, -3. Domain x greater than or equal to -5. Otherwise, you got imaginaries. You got negative. Can't have that. And the range, y values are less than or equal to -3. I want to start talking domain and range more now that you're starting to get a feel for these graphs. Doesn't matter what points you pick. I like 25. I like -2 times the square root of 25 minus 3. So I'm going to pick 30. I'm going to pick 20, excuse me. So it models this, and that's -10 minus 13. That's good enough. I see an exponential function. I see y equals 1. I see growth. I'm doubling. So I'll get a little doubling going. That's a differential. That's about twice the size. I'm going to pick 6, which is going to get me 2. And that's my initial jump, by the way, was 1. We don't have to write that, but my initial jump is 1. So that's a jump of 1. My next jump is going to be 2. If I pick the right number, and I do believe 7 gets the job done. 7 minus 6, 1, 2 to the 1, 2 times 1, 2 plus 1, 3. How far is it from 1 to 3? 2. Hopefully that's getting easy for you. E to the x minus 4, very similar function. I could turn it into a 2 to the, but I see a y equals 2. E is bigger than 1. So therefore I have growth. I'm going to drop a 4 in. If I put a 4 in, I get 1 plus 2 is 3. That seems to be that initial jump again of 1, providing I can make e to the 0. Okay, I just did. And I like to triple, so I've got to be a little bit bigger here than the last one. Let's call that tripling. 3, 1, 2, 3, pretty good. Well, I think I want e to the 1.1 minus 4. I want 1.1 plus 2. That's what I want, right? But I've got subtraction of 4, and I want 1.1. I think I want 5.1. So let's put 5.1 minus 4 at 1.1. I know that's 3 plus 2 is 5. You've been doing the other lesson sets, that's enough to talk about that. If you've been looking at the previous 19 lesson sets, then I should see x equals 2. If you've been doing it 19 times, that should be enough to realize that's the asymptote. And if it's not there, you have to assume you haven't done it 19 times. I don't have to assume, I know. Okay, so we want log base 4. And remember, log base 4 of 1/4 is -1. Log base 1/4, log base 4 of 1/16 is -2. We've been practicing that. So there's this negative tendency when I get towards numbers like 2 and 1/4. 2 and 1/4 is, what do I put on top of a 4 to get a 1/4? -1. So I get -5. So 2 and 1/4 gets me -5. I'm going to do more than 2 points here because we got to start understanding this trajectory here a little better. And 2 and 1/16 is even closer. Well, that's a bad location for that. So this thing keeps going down because at 2 and 1/16, which means I'm getting closer to x equals 2 on a number line, I'm getting closer. And that means I get -2 times 5, which is -10. Seems like that's a jump of 5 units. Wow, isn't that interesting? Wonder what happens when I put a 2 in there. Well, that's undefined. So how about, let's put just the number 3 in here. Because 3 minus 2 gets me 1. And I hope you see that's 0. Oh yes, I'm going up by 5. That's up by 5. That's up by another 5. That's up by another 5. Starting to take me more and, oh, geez. Yeah. So what's the next number that I want to plug in here? Well, I think I want to make the number 4. So I think I want the number 6. Yeah, 6 minus 2 is 4. That's 1. Oh, that is up 5. Then I think I want the number 16, which I think is 14. Oh, no, -2. So 18. I think I want 18 units. 18 minus 2. 6. Trying to get nice, friendly numbers. And that's 10. Oh, geez, I do see a pattern. And understanding math is all about understanding patterns. Yeah, that's a little more detailed logarithm. Guess we can go to more detail with things we've been studying for a while. ln, well, I see x equals 3. And I put it in the same position I did before. And what do I have? Well, I have numbers I know. I know the ln of 1 is 0. I know the ln of 2 is 0.7. Approximately, the ln of 3, I should use approximation symbols, 1.1. Although I said in the last video, the ln of 1/2 was -1.1. Because I'm talking to you and making mistakes. Should have been -0.7. Yasser will find that and he'll put it there. Remind me to put it in the introduction place on YouTube. All right, so I think I want numbers like this. Well, how do I get 1 out of this? I think I pick a 4. And I know I get 0, and 0 times anything is 0. And I know ln of 3 gets me 1.1, so I think I want a 6. And that's going to be actually 3 times whatever this distance is, which is 1. That's going to be 3 times that. That should give me 6, right? 3 plus 3, 6. Oh, yeah, that's ln of 3. ln of 3, 1.1 times 5, approximately 5.5. I think I probably could come down here with ln of a third. ln of a third means I'm picking, what, 3 1/3? Which is close to 3. 3 1/3 is close to 3, and that's going to get me -1.1. 1/3 gives me -1.1. That gives me -5.5. Geez, like the last problem, instead of going up by 5, I've created something that goes up by 5.5. And I think I could probably look at this and say, well, the next one is probably 9 units, which means if I go up 5.5, I should be at 11. 9 gets you 11. We don't like that. The numbers have bad meaning. But let's plug it in and see. 9 minus 3, 6. What's the ln of 6? The ln of 6 is 2 times 3, which is e to the 0.7 times e to the 1.1, which is 1.8. What am I doing now? Interesting. Yeah. Yeah, I guess I'm looking at how the x's are changing somehow here, huh? Yeah. Yeah, so anyway, 1.1, 9 minus 3 is 6. ln of 6, 1.8 times 5. 1.8 times 5. Well, let's see what that is. 5 times 8 is a 0 and a 4. Oh, yeah. Yeah, I'm going up about 9 units. Interact must be a coincidence. Okay, now I've got sun problems. Renee, we're going to have to deal with this, but I don't think we have to deal with it quite yet. So 2x minus 6 is a linear function going through at 3. That goes through the x-axis at 3, and x plus 9 is a linear function that is not going up quite as fast. And I'm multiplying those two things together, and that looks like that goes through the x-axis. I think I got 9 gets me a negative 9 gets me a 0, and 3 gets me a 0. That's helpful information. And I don't have my eraser. So let's cut to the chase. I know that 2x times x is 2x squared. So therefore, I know I have a cup shape up. I just found out that 3 makes a 0 and negative 9 makes a 0. Negative 9 makes a 0. 3 makes a 0. Oh, then I guess what's in between them, which is an average, negative 9 plus 3, which is negative 6 divided by 2, tells me negative 3 is going to get me my minimum. And if I drop negative 3 in, I get negative 6. I get negative 12 times 6. Oh, it looks like it's minus 72. That's something. Doing it fast now, so should I check it and see if I made a mistake? I don't know. I don't like 72 units of change. Negative 3 to 9, I like that now because that's 6 units, and when I square 6 units, I get 36. 72 divided by 36 is, yes, the coefficient of x squared. Yeah, must be a coincidence. All right, can't even see that problem with the sun. It's such a glare. So we'll move it over here. Hopefully we got our quick practice for the day. Maybe got a little better at something, a little quicker and better at something, but now I got to look at this. Sine of x plus pi. Pi equals sine of x plus pi. Well, I know the sine function. We usually start frame of reference, no radius, distance, right? No radius, distance. Let's go 1 radius length. There's 1 radius length. Let's go 2. Let's go 3. Let's go 3.14 right there. Let's do 3 pi over 2. 2 pi. Oh, 0 to 2 pi is once around the circle. That's 1 period. What am I doing with the circle? Sine measures height of the triangles drawn in the unit circle. I guess they're going up in the first 90 to 1, down back to 0 over here, to negative 1, and then back to 0. So that's 1 period of the sine function. So 1 period of the sine function gets me numbers between 1 and negative 1. And it starts at 0, except this one doesn't start at 0. This one starts at negative pi. When I put negative pi in, I get 0. And I get what I just talked about. So the negative pi gets me 0, and I know 2 pi. 2 pi is once around the circle, so I guess it ends at pi. Brings me back to 0. Then I think I got all kinds of symmetry where this goes through the origin between negative pi and pi. And I guess this is minus pi over 2. Gets me 1. And it looks like pi over 2. So what did I say? Negative pi over 2, positive pi over 2 gets me negative 1. You can check those out. I think you can check those out. Yeah, I think if we put negative pi over 2, or pi over 2 in here, pi over 2 plus pi is 3 pi over 2. 3 pi over 2 is right there on the circle, and that gets me negative 1. Yeah, guess it does. Yeah. And this was originally x plus pi. Yeah, okay. So the period of this is still 2 pi. And we'll be changing the period of this later, because we'll be multiplying things by 2 in here and dividing by 2 and seeing what happens to this, whether it happens quicker or slower, that 1 period of revolution. We'll find out as we continue to study. All right, so that was a quick one because somebody's going to be using this room soon. We've got a big group of folks coming in here today, so I got to get out of here. So hopefully that was enough practice to move the needle in the proper direction towards more understanding. As Yasser would say, stay safe and warm.